अरे अभी क्या?
वीडियो स्टार्ट कर देते हैं. Okay, चलो let's continue people. We have one more एक छोटा सा exception left in tetrahedral complexes in coordination number 4 complexes. Cu NH3 4 the whole raised to 2 plus. Chalo, over here, quickly give me the atomic number of copper. 29. Configuration please. Argon. Excellent. 3D9, 4s1. Now, pardon me. 3D10, 4s1. Now, what is the charge on copper over here? Plus 2. Copper क्या बन जाता है? Give me the configuration with Cu plus 2. So this becomes 3D9 4s0. Okay, 3D9 is something like this. Correct, and this is 4s. We also have empty 4p. Now what happens here is, you see this unpaired, shift this electron to 4p. So configuration looks something like this. ठीक है, and now we have to accommodate 4 lone pairs by which ligand? H3. So 1, 2, 3 and 4. What will you write here? Electrons from ligands. Quickly give me the hybridization. Hybridization is DsP2, and what is the geometry people? Square planar. Number of unpaired 1, magnetic moment root of n into n plus 2, that is root 3. Jaldi copy the exception. Thank you. Please write down limitations of crystal field theory. Limitations of crystal field theory. Just write key points. CFT is successful in explaining. CFT is successful in explaining formation, structure, color, and magnetic properties. Formation, structure, color, and magnetic properties of coordination compounds. However, the assumption that ligands are point charges means that anionic ligands should have maximum crystal splitting effect. However, we know that anionic ligands are at the lower end of spectrochemical series. Lower end of the spectrochemical series. It does not take into account, next point, CFT does not take into account the covalent bonding nature between metal and ligand. Some of these limitations are explained in ligand field theory. Some of these limitations are explained in ligand field theory, LFT. But people, LFT is out of scope for us. People, I had missed a point. We have written the relation between the splitting energy in tetrahedral and octahedral, but हमने square planar का relation लिखा नहीं था. So please copy this relation. जहाँ हाँ वो जो tetrahedral का लिखा था उसके बाजू में आप कॉपी कर सकते हो. That's it. We also have to do, some numericals based on CFT. But क्या करेंगे? CFT will complete isomerism, and then probably an hour we'll just do questions on isomerism and on CFT. This is square planar and octahedral, and this is the general trend. तो ये भी आप कॉपी करके रखो. हाँ लेक्चर के बाद में डन पीपल. चलो प्लीज राइट डाउन. Isomerism in coordination compounds. We start with the first one, structural isomerism. We have structural and we have stereo. Stereo has geometrical and optical. We'll start with structural isomerism. Write on the first one, people, in that. I'm sorry. Ionization isomerism or ionization isomers. Right now. In ionization isomerism, the counter ion is itself a potential ligand, and can displace a ligand, which can then itself become a counter ion. Next point, they produce different ions in aqueous solution. They produce different ions in aqueous solution. Chalo. Now, if you look at this example, people, board pe, so I have CONH35BrSO4 and the same over here, but people, Br here is part of the complex, so it's part of the coordination sphere. So basically it is ligand, and SO4 is part of ionization sphere. or it is the counter ion. We can actually switch places यहाँ पे. SO4, which was part of the ionization sphere, can be part of the coordination sphere, and the same over here. So what is the relation between two? We call them as ionization isomerism or ionization isomers. Now I want to test these. So let's say if I treat this with excess of AgNO3, ठीक है. So what will I get here? और let's say कि मैं इसको change कर देता हूँ कलर के लिए. I'll put Cl here. और यहाँ पे क्या हो जाएगा फिर? Cl. Now give me, if I treat this with excess of AgNO3, this will dissociate in the form of CO NH3 phi Br plus and plus what do I have? That is going to give me AgCl, color white PPT. What about here, people? This gives me AgBr, color pale yellow. And that's the second point. What's the second point that we have written? They produce different ions in aqueous solution. Did you people get that? बोलो रे. चलो. Leave space to copy this. बाद में एक साथ copy करना है. Write the second one. Hydrate or solvate isomers. Hydrate or solvate isomer or isomerism. Bracket में you can write down subset of ionization isomerism. Subset of ionization isomerism. Please write down subset of ionization isomerism. These isomers have different number of H2O molecules. Different number of H2O molecules inside bracket में you can write coordination sphere या coordination entity and outside the complex. Next point. Solvate isomerism differs by whether or not a solvent molecule is directly bonded to the metal ion. or merely present or merely present as a free solvent molecule, merely present as a free solvent molecule trapped in the crystal lattice, trapped in the crystal lattice. For example, okay, now pay attention people. So let's say we have this particular coordination compound, okay? It can have these three forms. A simple way of understanding hydrate or solvate isomerism is different number of water molecules present inside, and so in the coordination sphere and in the ionization sphere you'll have different number of H2 molecules. वो simple way में understanding है. But these H2 molecules which are present outside, last point में देखो क्या लिखा है, where are these present? These are trapped inside the crystal lattices. So it's not that they have any specific bonding present. They're inside the crystal lattice, there will be some void, there will be some place available, and these water molecules will be trapped inside. However, हमने एक specific example भी पढ़ा है. So it's not necessary that it will always be like trapped inside the crystal lattice. For example, look at this particular specific example. क्या बोलते हैं इसको? CSO4.5H2 blue vitriol. Now इसका structure, anyone remembers we did this 11th standard? तभी ये सब जानिए होगा because we बोलते हैं coordination compound में हम पढ़ते हैं. So this is your central metal Cu2 plus. Next we have H2O here. So how many H2 are present inside the coordination sphere? 4. One outside, but that one outside has hydrogen bonding. So either the water molecules which are present outside will be trapped in the crystal lattice, or if there's a possibility they might even form hydrogen bond. Did you will get that? Jaldi copy this. Thank you, Ravi. Now people, the next isomer you people have to tell me. You have to explain karo, what do you understand in this. So if I give you first example. What do you see here? Here the central metal atom is bonded to cyano, and here these are what ligands? What type? Excellent. These are ambidentate. What were ambidentate? Different donor but same ligand. Yes or no? These are called as linkage isomerism, or this is linkage isomerism. Now this is observed in case of ambidentate ligands, where the central atom is bonded to here carbon of the cyano, but it is bonded over there to nitrogen. Did you will get that? Please write down linkage isomerism. Yes, all these are under structural isomerism. Observed in case of ambidant ligands, observed in case of ambidantate ligands where there are two possible coordination sites, where there are two possible coordination sites. And quickly copy the examples. In first case we have cyano and isocyano. In the second case we have nitro and nitrito. जल्दी जल्दी. If you're done with that, observe the next example and tell me about this. How do you explain this particular isomer? What are we just doing here? Exchanging their, we're just exchanging their ligands. Please write down the next type. Coordination isomerism. Coordination. Yes, we are doing structural. Coordination isomerism. Coordination isomerism. These isomers are obtained. These isomers are obtained due to the exchange of, these isomers are obtained due to the exchange of ligands between, these isomers are obtained due to the exchange of ligands between cationic and anionic complexes. Copy the examples. Next, please write down. The next type of structural isomerism that we have is called as ligand isomerism. Now look at the example. Can someone give me the relation between ye and ye? If you see, everything is same, but yahan pe there is isomerism. So there is isomerism between the ligands. We call them as ligand isomerism. Please write down. Short form में लिखेंगे. Isomerism within the ligand itself. Isomerism within the ligand itself is ligand isomerism. And then copy the example. And the last one in structural isomerism. And the last example, the last one that we have in structural isomerism is, please write down, polymerization isomerism. Polymerization isomerism. Right on. They have, or isomers having the same empirical formula. Same empirical formula. Same empirical formula. Copy the example on the board. Yes. And pause the. After very productive discussion, let's continue. Abhi, we are starting with geometrical isomerism in coordination number 4, that is square planar complexes. ठीक है? Now, before we get into आइसोमेरिज्म थोड़ा सा एक दो टर्म्स याद रखना है. Wherever we write small a, b, c, d, these represent monodontids. ठीक है. So if I write छोटू a, छोटू b, छोटू c और छोटू d, that is monodontid. If we write capital AA, then this is symmetrical bidontid. What do you mean by symmetrical bidontid? Both the donor atoms are same. For example, ethylene diamine. What are the donor atoms in ethylene diamine? Nitrogen. So if we write ये दो दोनों donor atoms है. And if we write AB, then this is unsymmetrical bidontid, or where donor atoms differ. Capital M will stand for central metal atom. Now, coordination number 4, square planar geometry. Let's start with the first one. Square नहीं होता ना. चलो ठीक है. Now, so let's say if I have M A2 D2. Start with the first one. What does M here represent? Central metal atom. A and B hetero या homoleptic complex है? Hetero. Center में कौन आने वाला है? We have M. As people remember, this is square planar. These are all coordinate bonds. I'm not making them, but अच्छा चलो एक वाले के लिए बना देता हूँ. Now, select the ligand which is repeating twice. AB is repeating twice and B is also repeating twice. Remember, geometrical isomerism में there were multiple nomenclature, but सबसे basic nomenclature हम कौन सा पढ़ते थे? Cistrons. So for M A2 B2, if I want the cis isomer, I repeat, select a ligand which is repeating twice. So ये A B B. Now there are two ways to understand this. A on the same side, we call it as cis. A को बना दो here, the other over here. This will become trans. Or the other way to look at this is, what is the angle between A over here? 90 degrees. So यहाँ पे the angle between A is 90 degrees. What is the angle over here, people? 180 degrees. So cis angle will be 90 degrees and trans angle will be
180 degrees.
cis angle को 90 ले लेंगे, trans angle को. ये coordination number 4 तो काफी easy है. A on the same side या AA diagonal opposite side. Remember, I want coordination number 4. So what can be the next type? Now exam में ऐसे नहीं आएगा. Exam में probably they'll ask you that, let's say I have this particular coordination compound. What type of GI can it show? Can it show geometrical isomerism? Yes. How do I compare? PT is M. This is your A2 and this is your, can you draw the structure? Chalo. Can someone tell me how will the cis form look like? NH3, NH3, Cl and Cl. This is cis form. इसका नाम है cisplatin. A very important anti-cancer drug. Can you people make the trans form? ठीक है, trans आप बना देना. And hence people who general form is important. बाद में all you can do is if the complex given उसको आप compare करो, it is matching with general formula और वैसे आप उसका GI बना सकते हो. Next, coordination number 4 चाहिए. So we can have M A2 B C. Can someone try and tell me how will the cis form look like? AA BC, or you can write AA and BC. When you try to learn this from an angle perspective, वो ज़्यादा अच्छा है, ठीक है? For example, see, because we are saying that pick the ligand which is repeating twice, but I said it doesn't really matter. These are the only two forms in which this particular coordination compound can exist. What is the angle between A and A over here? 90 degrees. What's the angle between A and A over here? What is the angle between B and C over here? Angle between. So though we are saying that this is AA cis, AA trans, I can say this is BC cis. कुछ भी उठाओ, I can say this is AB cis. तो अगर मुझे AB trans बनाना होता तो मैं क्या करता, इनको स्वैप कर देता. But these are the only two forms which are available. All others will be similar to यही दो structures. Getting that? चलो next. थोड़ा सा नीट बनाने के लिए ना वी कैन ऑल्सो एक यहाँ पे कभी कभी बॉन्ड भी दिखाता है वो, मतलब बॉन्ड नहीं, आई एम सॉरी, बट टू शो द स्क्वायर, वैसे स्क्वायर प्लेनार, ठीक है. नेक्स्ट वी कैन नेक्स्ट हैव M AB CD. Now here none of the ligands are repeating twice. तो किसको भी ले लो. Let's say I pick AB. So A B. What is the angle between AB people? 90. A B. Angle between AB? C D. Getting that? But यहाँ पे एक problem है. See, though it is AB cis, who's next to A over here? Who's next to B over here? I can also have एक और configuration in which AB remains where they are, D here, and both the configurations here can be called. So A के बाजू में कौन है? C. B के बाजू में कौन है? Pick any two random combination. Pick BC. So where is BC cis? BC cis. BC cis. Why? Because B का who's next to B over here? Who's next to B over here? Sorry, D A. Sorry, C का next is A and B का next is B का next here is A and C का next here is D. And यहाँ पे we can have BC trans. Pick any two. Let's say I pick CD for reference. This is CD on the same side, cis. This is also CD on the same side. but who's next to C? यहाँ पे C के बाजू में कौन है? And this is CD trans. Basically, if I have M, A, B, C, D, it can have only these three variations. Did you will get that? Next, let's say I have M A4. How will the cis configuration, how will trans configuration look like? This is cis and this is, so will there be any GI possible? What about this? No GI possible. Let's say I have M A8 twice. Let's take an example. M En twice. En is ethylene diamine. So center में what do we have? M. There are two ways to do this. Ethylene diamine पूरा बना सकते हैं. NH2 CH2 CH2 and same here NH2 CH2 CH2 and this is one form. Can there be any other form? Remember, it's a कैसे? Where? Above the plane. So for example, NH. Let's take this board as the example. So where is this NH2? Top left corner. Where is this NH2? And this goes like this. Similarly, that goes like that. Yes or no? That can be one form. What can the other form be? यहाँ से ऊपर से वैसा. Yes or no? Very good. It is square planar. What do you mean by planar? On the same two-dimensional model. यहाँ से ऊपर से उठा के लेके जाओगे, so that'll become a three-dimensional model. Possible है क्या वैसा? So M A twice. This also has no GI. What about M A B2? How will you make M A B2? कोई भी एग्जांपल ले लेते हैं. Let's say M En Cl2. En is ethylene diamine. शॉर्ट फॉर्म में ethylene diamine ऐसा शॉर्टकट में ऐसे ही बना सकते हैं. Cl. What can be any other form of this? You can put Cl here or take En ऊपर से. Possible है क्या? Nope. So will this show any GI? Nope. What about M A B C? Will it show? M A B C. Cl here, Br here, Br ऊपर Cl नीचे. ऐसा पॉसिबल है क्या? Nope. Same. इसलिए तो I'm writing it there ना एक साथ. No GI. Getting that? But there is one left. Can someone tell me one combination which is left? M A B2. M A B twice or M. Can someone tell me a unsymmetrical bidentate? Excellent. Glycinato twice M. So which were the donor atoms in glycinato? Excellent. Oxygen and CO CH2, and here it was NH2. यहाँ पे भी you'll have COO CH2 and then NH2. Getting that? This is which form? Cis form. Cis के बाद how will I make the trans form? Any guesses? इसको कर दिया COO minus and यहाँ पे लिख दिया NH2. Getting that? Yeah. If you want to know the general form, AB. This is cis. How will the transform look like? AB BA. None of the geometrical isomers are optically active because all of them have a POS. What is POS? So the next class we will start with coordination number 6, isomerism. समझा? ठीक है? Excellent. Thank you people. Very nice. Very smart and intelligent, hardworking kids.